We're still talking about heterogeneous catalyst, and one disadvantage in this catalyst is known as catalytic poisoning. When the reactants rather react with the catalyst and they stay on the surface and make that surface obsolete and ineffective. One case that we like you to know is catalytic converters in the cars. Underneath each car there is a box, and it contains the following precious metals: platinum, rubidium, and palladium. And what happens is you usually in the combustion engine you have carbon monoxide and nitrogen monoxide. Both are harmful and poisonous, and also you have some hydrocarbons. They come in contact with these metals and they exchange oxygen and produce carbon dioxide, which is not poisonous, just a global warming agent, and nitrogen gas, which is inert, and you release it back to the environment, in addition to steam and water. So this is catalytic converter, and it contains the following metals. Now this catalysts get easily poisoned by lead. So if somebody uses leaded gasoline, the catalyst in the catalytic converter becomes poisoned and obsolete. Also internationally, the theft has been up. Many people are not stealing cars, they rather steal these boxes. They cut it off in order to get access to the precious metals and sell them. Now, how do you pick and choose a catalyst? So there are some properties that you should be familiar with, and if you are being questioned, you should be able to answer it. So the catalyst should be strong selectivity for the desired product. That's the first thing. If it doesn't speed up the reaction, it's obsolete. It should be able to work under stress condition of high temperature and high pressure. So you have to be able to pick and choose a catalyst that is not going to destroy at severe environment within the reaction vessel. Environmental impact, meaning that if you need to dispose the catalyst, it shouldn't add to environmental problems. These two are connected, but you can use them separately. One is cost and lifetime. The catalyst should be cheap if you are in chemical engineering or manufacturing, so you can make some money out of that reaction. The lifespan or lifetime of the catalyst is important, so you can reuse it before it gets totally destroyed. And also it should not be poisoned rather easily, or you should have ways to stop this. The last one is extremely important. It's known as conversion efficiency. We want the smallest possible size in order to have the largest possible surface area. So as size goes down, surface area goes up, and that's where the new industry of nanoparticles and nanocatalysts is coming to life. Now they're going after, first thing you should realize, nanometer is, for example, 10 to minus 9 meters. 100 nanometer is size of a virus. In this picture here, if you don't see, this is the length of 2 nanometers of, and usually we have them embedded in carbons, in nanotube of carbons, or fluorines, buckyballs of carbons. So here they have a platinum and iron catalyst embedded in the size of this sort of nanoparticle. And it speeds up the reaction because now you have such a small size that is capable of speeding up the reaction. One other example that IB wants you to know is a natural catalyst known as zeolites. Now zeolites are cage-like, they are porous, and the size is small enough for water to go through, for example, but it captures the cation. The cations, the heavy metals that are poisonous to our health, they go inside and they get trapped in it. So these are the properties of zeolite. It's microporous. It has lots of tiny microscopic holes. It's aluminum silicate, so it is cheap, plentiful, and naturally occurs as an ore, or we can duplicate it and make it as aluminum silicate. So it has aluminum, silicon, and oxygen as its atomic structure. It works like a natural sieve, so it just sieves through something and traps other stuff in it. This is why we use it for. It removes heavy metals from water, and also sometimes you add it to detergents in places that you have heavy water because they have calcium and magnesium and other metals in them. so it sort of softens the water as the washing is going through.